Have you ever wondered what everything around you is made of? This simple curiosity led to the birth of atomic theory. It all started around the 5th century BC with two Greek philosophers, Democritus and Leucippus. They proposed a bold idea that turned heads in the intellectual world. They suggested that everything in the universe, all matter, is composed of tiny, indivisible particles. They called these particles atoms, from the Greek word atomos, which means indivisible. Fast forward to the 17th century, and we find another significant contributor to atomic theory, Robert Boyle. Boyle was an ambitious man of science, and he took the idea of atoms a step further. He suggested that the chemical elements, the basic substances from which all matter is made, are themselves the simplest forms of matter. In other words, elements are made up of atoms, and these atoms are the building blocks of everything. This was a revolutionary concept, one that challenged the established understanding of the world. The idea of atoms being the smallest, indivisible particles of matter was no longer just a philosophical concept. It had entered the realm of science. From philosophy to early science, the atom was seen as the building block of everything, but its journey was just beginning. Fast forward to the 19th century, a time of revolutionary discoveries. The narrative of the atom takes a significant turn with John Dalton, an English meteorologist and chemist. Dalton's keen observations led him to propose the atomic theory of matter, suggesting that each chemical element consists of atoms. He stated that atoms of the same element were identical, and different elements had atoms of varying sizes and properties. This theory provided a new lens through which to understand the physical world and laid the groundwork for future explorations. As the century progressed, another groundbreaking discovery came into light. Joseph John Thomson, a British physicist, stumbled upon a new component of the atom, the electron. Thomson's experiments with cathode rays led him to the conclusion that atoms were not indivisible, as Dalton had proposed, but contained smaller particles, which he named electrons. These negatively charged particles were much smaller than atoms and existed within them. This revelation shook the scientific world, challenging Dalton's atomic theory and opening up a whole new world of subatomic particles. The 19th century set the stage for a new understanding of the atom, a structure far more complex than previously believed. These breakthroughs marked the beginning of a journey into the heart of the atom, a journey that would continue to unfold in the years to come. As we step into the 20th century, the atomic model further evolves. Enter Ernest Rutherford, a physicist from New Zealand who proposed a new model for the atom. He envisioned the atom as a mini solar system with a central nucleus surrounded by electrons in orbit, similar to planets around the sun. But what's inside this nucleus? Well, Rutherford's student, James Chadwick, an English physicist, answered that question. He discovered the neutron in 1932, a neutral particle that, along with the positively charged proton, makes up the atomic nucleus. This discovery was crucial, as it explained the mass of atoms and set the stage for the understanding of nuclear reactions. But hold on, how do these electrons orbit the nucleus without crashing into it? Niels Bohr, a Danish physicist, came up with a solution. In his model, electrons orbit the nucleus in specific energy levels. They can jump from one level to another, absorbing or emitting energy in the process, but they can't exist in between these levels. This model helped explain how atoms interact and form bonds, leading to the creation of molecules and ultimately, everything around us. The 20th century brought us closer to understanding the intricate structure of the atom, a world within itself. The understanding of the atom not only revolutionized science, but also had profound implications for the world. The year 1938 marked a pivotal point in the atomic journey. Scientists discovered the phenomenon of nuclear fission, where heavy elements like uranium can split into lighter elements. This process releases massive amounts of energy, and it was this understanding that paved the way for the creation of the nuclear bomb. The application of nuclear fission technology took a devastating turn during World War II. In 1945, 2 nuclear bombs were dropped on Hiroshima and Nagasaki, Japan. The destruction was immense, and the world was introduced to the terrifying power of the atom. But the atomic journey didn't end there. Scientists continued to explore the possibilities of nuclear reactions, leading to the discovery of nuclear fusion. In contrast to fission, fusion is a process where light atomic nuclei combine to form a heavier nucleus. The energy released in this process is tremendous. It's the same process that powers our sun and all the stars in the universe. The discovery of nuclear fusion led to the development of the hydrogen bomb, also known as the thermonuclear bomb. This weapon, even more powerful than the atomic bomb, relies on nuclear fusion. The first hydrogen bomb was detonated in 1952, marking another significant, albeit frightening, milestone in the journey of the atom. The atom's journey, from a philosophical idea to a scientific reality, has shaped our world for better or worse. The power within the atom has been harnessed to create weapons of mass destruction, but it also has the potential to provide abundant clean energy. As we continue to explore the atom's potential, we must strive to steer its power towards the benefit of humankind and away from its destruction. Today, the atom stands at the center of debates over peace, security, and the future of our planet. Nuclear weapons pose a grave threat to international tranquility, prompting global efforts to curb their proliferation and use. The atomic story doesn't end here, though. We're delving into the distinctions between nuclear fission and fusion as we strive for cleaner, safer energy sources. The atom's journey, from philosophy to the bomb, is a testament to human curiosity, ingenuity, and the power of scientific discovery. Yet, it also serves as a stark reminder of the responsibility that comes with such knowledge.